have to do both a graph and a table?
No, so the reason I have those tables there is so that you can more clearly see the points. Notice there's no grade for the table. It's accurate graphs. Personally, what I did is I came in and I looked for, using the understanding that this is y equals mx plus b. I personally said, okay, so there's nothing there, so I know it has to be a 1 time, so my slope is 1 or 1 divided by 1. I know my y-intercept is 3. So up, 1, 2, 3 on the y-axis with a slope of 1. Or negative 1 divided by negative 1 is also positive 1. So there's my graph. However, if you're looking at that and you don't recognize what your slope and your y-intercept are, what's a good representation to help you get there? The table. So the table is just there for anyone who created the table because they weren't sure about slope and y-intercept. Because notice if I plug negative 2 in, what's negative 2 plus 3?
2.
Negative 2 plus 3. Right? Plug in a negative 1. What's negative 1 plus 3?
2.
Plug in 0. 0 plus 3.
3.
1 plus 3.
4.
2 plus 3.
5.
So it's just that table can help you if you're stuck on identifying slope and y-intercept. I cannot emphasize this enough.
I asked because I made like somewhat of a table.
Yeah?
And I did the graph on number 10 and 11.
Well, notice we're on 3 and 4 right now. Right? So you don't need to be looking at 10 and 11 yet. 3 and 4. Okay. Some people were asking earlier, right? So solve the following systems by graphing. They say solve it. Well, but how is a graph going to solve this system? Shouldn't be looking blankly. You should be thinking about this. Why would solving this system include this idea of graphing?
Okay, make it equation.
Okay, so remember, if you're solving, you're looking for a solution. What is a solution?
The answer.
Not the answer. It's closer to what you said just a second ago. Because remember, can you get an incorrect answer?
Yeah.
But the solution is the solution. You can't have an incorrect solution. You may have messed up and got an incorrect answer, but the solution is only what makes the equation true. Remember, every point on this blue line makes this blue equation what? True. Every point on this brown line makes this brown equation true. Right? That's the whole point of the graph is here are all of my solutions. Here are all of my solutions. So what's the solution to the system? What makes both equations true?
0, 3.
That point of intersection, 0, 3. Now that I found a point, a solution to both equations, I have solved it. Right? The point of intersection so that's a good question. Right? The point of intersection is a solution to both equations. Therefore, the system is solved. Remember, I don't write things on the board for my own health and sanity. These are things I know. These are things that you probably need to know. I'd write this information down. Because these are your notes, right? Even though this is homework, this is a good opportunity. You should have been able to do this, but that's a good note to have in the future. That point of intersection is a solution to both equations, therefore the system is solved. And notice I plugged both points in, or the point into both equations. Did that point make both equations true? Yeah. 3 in fact does equal 0 plus 3. That's true. Negative 2 times 0 is
0.
0. 0 plus 3 is 3. So that made that equation true, right? Now, so the whole point of that point of intersection is that is the solution to both equations. That's the solution to the system. Make sure you indicate how many percentage points you earn on each of those. So put plus whatever. If you got both graphs, but that was it, it's plus 10. If you got both graphs and you indicated that point of intersection, 5, 5, 5 would be plus 15, right? Plugging it back in is an extra 10. Any questions before we move on? Good? Okay, so make sure you add your percentage on there. One thing I do want to note on number 4 before we move on, because it's y equals negative x, that's a little bit harder for some people to identify their slope and their y-intercept. What do you think the slope would be here?
1.
Not 1.
Negative.
-1, right? The 1 is the only thing you don't ever have to show being multiplied, but because it's negative, it's a -1. What would be the y-intercept?
0.
Yeah, the only thing I don't have to add is a 0. And so notice y-intercept of 0, slope of -1, which means down 1 to the right 1. Notice that's -1. Or that could mean up 1 and to the left 1. That both of those are -1s. So up 1 to the left 1. There it is. But what other representation can you always create if you're stuck, not sure about the slope and the y-intercept? A table. Hopefully you started to pick it up. What x values do I typically like to use?
Negative. Low ones.
Yes. Specifically, I start in the middle at 0, because that's going to give me my y-intercept, and then I move to either sides. I'm going to show you in a case where I didn't do that in a minute, but notice there it is. Those are things I'm going to plug in, because if I look at a negative x, so negative times -2, what is negative times -2?
Negative. Positive 4.
Not positive? Oh yeah, no, not positive 4. Just a negative times -2.
Oh, 2.
Positive 2. Negative 2, 2. What's a negative times -1?
1.
1. Negative times 0.
0.
See how that gives me those points so I can just graph them. I'm okay with you not being 100% comfortable with slope and y-intercept and just graphing from there. We should start to develop more comfort with that because you covered it with me or Miss Anderson last year. We've seen it multiple times and we reviewed it at the beginning of this year. So you got to be able to graph, and then you just need to realize, hey, that solution, that's my point of intersection. There we go. Where is the remote? There it is. Okay, here's the next set of problems. What questions do you have off of this? Please notice accurate graph, that is 10%. Identifying that the point 3,5 is not a solution, that's 5%. And identifying 2 more points, those are 5% each. Notice I didn't tell you what points you have to have. I just said any of the points that are marked are solutions, and you just had to pick 2 of them. Right, so any points are solutions. What questions do you have before we move forward? Go ahead and indicate how much you earned, by the way, as well. So look to see there what you've earned. And if you didn't do it, make sure you at least take some notes to study later.
I had trouble with 11.
Yeah? Good. It's a great question to ask about. Any questions about 10 before we look at number 11?
10, 15%.
Say again?
10, 15%. Out of 15.
It's 25 again. The graph was 10%. The point was 5%. Identifying that it was not a solution. And then the 2 more points, each point was 5%.
Oh.
So 10, 15, 20, 25. Right? Because we have to add up to that 100. Right? So no questions about 10. Ready to look at number 11? Okay. So in number 11, again, personally, I'm going to identify my slope and y-intercept. What does it look like my slope is? 3/5. Remember, we're multiplying here, and that's a good thing to notice because what is multiplication? Repeated addition, right? So I know that that's my slope. And what would be my y-intercept? 4. So I started at a y-intercept of 4. 1, 2, 3, 4. And then if it's a 3/5, you just need to remember the way we usually calculate slope is rise divided by run. So up 1, 2, 3, to the right 1, 2, 3, 4, 5. Positive is up and to the right. Now, this could have also been a negative 3 divided by a negative 5, because what's a negative divided by a negative?
Positive.
It's also a positive. See how I could have used that to go down 1, 2, 3, and to the left 1, 2, 3, 4, 5. You good with those ideas? Make sense? However, do you have to use slope and y-intercept in order to graph it? What else could you create? A table. Now, this is the problem I want to look at to indicate when I would not go by ones. What's the x value I'm going to choose in the center? Where am I going to center my x values?
4.
0. The y value is 4, right?
Oh, yeah.
Notice I'm pretty much always centering at 0 because what is the output when the input is 0?
The output.
But what do we call the output when the input is 0? The y-intercept, right? I want to find that y-intercept. That's important. Now, here's the thing though. If I plug in a 1 here, 3/5 times 1 plus 4, that's going to give me a fraction. Do you want to deal with a fraction?
Never.
Never, right? Neither do I. So notice, what am I dividing by? 5. So I'm going to go by 5s. Notice this. What is 5 divided by 5? What's 3 times 1? 3 plus 4?
7.
Man, isn't that way easier than having to deal with a fraction? Try a 10 here. Now what is 10 divided by 5? 2. What's 3 times 2? 6 plus 4. You can even do it with a negative 5. What's negative 5 divided by 5?
Negative 1.
3 times negative 1
Negative 3.
plus 4.
And negative 1.
You're right. And I'll remind you, can you use a calculator to do those calculations?
Yeah.
Sure, 100%, but I'm going to still go by 5s because I don't want to deal with decimals, I don't want to deal with fractions, I want those nice integer whole numbers. Notice that matches rising 3, running 5. There's my line. Is 3, 5 a solution? No. Why is it not a solution? It's not on the line, right? Remember, you're only going to graph the solutions to that equation, the things that make the equation true. We go with that, those ideas. Ready to move on? Have we written down how much we've earned? Yes? Okay. I want to take this as a moment. I know y'all are probably tired of hearing me say this, but please hear me very clearly on this. You got to do homework. We talked about it in second period, and I want to bring this up here because this is probably a small thing that a lot of students have missed, and I know it's hidden right now, but this guy right here is a poster I've had up in my room since I started teaching. His name's Steve Prefontaine. He's probably celebrated as one of the greatest American runners, distance runners that's ever been. He went to the Olympics, set a bunch of records when he ran for Oregon. And this is a very famous quotation from him. To give anything less than your best is to sacrifice the gift. I know that at times it's really easy to just not do anything. To go home and play video games and watch Netflix and watch stuff on Disney Plus and all those different things, because trust me, that's what I want to do as well. I get it. But if you give anything less than your best, then you're sacrificing the gift. And the gift that y'all have been given is a brain and a free education all the way through high school. In the United States, we're committed to making sure, or trying to make sure that you have the opportunities to be successful. If you give anything less than your best, you're setting yourself up for failure, unfortunately. Maybe not failure within this class, but eventually it'll start to come back to bite you. You got to put in your best effort. And when you do, great things can happen. I cannot tell you how exciting it is to find yourself start to become successful. Even in a math class, when you're like, man, I hate math. Nah, you start to get good at something, you start to care about it, right? So let's give our best. That includes putting in time both on the field and off the field. To reference football and baseball and every other sport. You got to put in practice time on the field and off the field. Same thing is true for your education. Hard work pays off because of the growth mindset that we studied earlier this year. Right? You got to put in time on the field, which is in our classroom. You also got to put in the time off the field. It means going home. And I'm trying not to give a ton of homework, but like tonight, 2 problems. But I need you to commit to do those 2 problems tonight. Last night I asked you to do 4. And I know that this was for an accuracy grade, but didn't we have 4 problems just like it the night before? So when you do it the night before it's an accuracy check, you can come in and ask the questions that you need to ask so that you can take notes and get better for when it is for accuracy. Make sense?
Yeah.
To give anything less than your best is to sacrifice the gift. You all have a beautiful brain. Use it. Develop it. Get better at it. Because you're capable of doing that. So let's get started with today. We're going to wrap up 5.1, the pet sitters group work, and then we're going to have a true wrap-up all together. I'm going to give you all a sheet of paper, graph paper that I want you to record information on when we all come together. But go ahead and actually we need to read objectives first, don't we? Yeah. Let's see here. Keltrick, can I get you to read our first objective for us?
I can identify the values that
Satisfy?
satisfy the
Constraints.
constraints of a world problem.
Okay. When we talk about constraints, there's things that limit what we are able to do, right? Now, academically, in terms of our brain, like we can always keep reaching for more, but like when we were looking at this case with Carlos and Clarita, they only had such a big shed, right? There was only a certain amount of space that they could fit their cats and their dogs into to make money. They only had so much money to be buying cages for both the dogs and the cats. So there were constraints there were limitations to what they could do. We still want to find values that satisfy those constraints. Let's see. Christian, had you read objectives recently? Can I get you to read the second objective for us?
I can create multiple mathematical representations to model values that satisfy the constraints of a word problem.
I get that sometimes we're looking at problems and it may be hard to recognize anything that's going on because it's just all over the place, right? So what are the mathematical representations that can help us bring order to the chaos that is happening?
Graph.
Graphs, right? Those are powerful. What other representations can help us bring order to the chaos?
Table.
Tables. What else?
Great.
Algebraic, right? Our equations, our expressions, our inequalities. What else? There's 2 more. They're not as heavy, but they're still good and useful.
A bar?
Say again?
A bar? A bar.
A bar? Well, that'd be a graph, right? That's typically for data, not as much for functions. What are you saying, Jaden?
Pictorial.
Pictorial, right? Drawing pictures. I haven't seen anyone do this yet, but I mean, like realistically, could you have drawn a picture to represent the space that the cat pens were taking up and the dog runs were taking up? Yeah, like you could have done that, right? There's one more, which is actually what this representation is.
Verbal.
Verbal, right? All of these different representations tell a different side of the story, but they all come together to tell the same story. And we want to see all those different things, and we want to use those mathematical representations to bring order out of the chaos so that we can find patterns, because when we can find patterns, our job gets easier. Okay?
Is that the one from yesterday?
What?
The object.
Yeah, these are the same 2. Because we've been working on 5.1 for the last 2 days. So it's the same objectives, right? I'm not changing those objectives up. This lesson has these 2 objectives. That's it. Make sense? Mm-hmm. All right, so we looked at the Martinez twins, Carlos and Clarita. They're trying to make the most money possible. But as we said just a second ago, and we talked about last few days, they have restrictions, they have limits, they have constraints, space, and startup costs, right? So y'all come up with some combinations of cats and dogs so far, right? I want you to take 5 to 10 more minutes, and I want you to identify the most money that you could find for your cats and your dogs. And I also want you to take that time to find one combination of cats and dogs that did not work so that we can talk about it. Those instructions make sense? So the combination of cats and dogs that made the most money and that worked and a combination of cats and dogs that did not work because of one of the constraints. Sound good? Alright, go ahead and start looking for that, identifying different values.
You got it?